Start with a few further examples relating to motion in a straight line, and specifically we'll be dealing with motion that is having constant acceleration. We have a question here, and as usual we have to first summarize our question diagrammatically so that we're able to have an overview of the question before we begin answering it. So in this question we're having, it goes that a particle is projected away from the origin or with an initial velocity of 0.25 meters per second. So we are having a particle. Let's say if this is our origin, it is projected from this point with an initial velocity u of 0.25 meters per second. The particle travels in a straight line and it accelerates at 1.5 meters per second. So meaning its acceleration right there is 1.5 meters per second squared. Find, part A, how far the particle is from O after 3 seconds. So we are required to find, let's say it has been moving from here. After here, it moved for first second, then the third second. So when the time is 3, what is the distance? They are asking how far is the particle. So what is the distance when the particle is 3 seconds away? So of course here, from our equations of motion or of constant acceleration, those equations we derived earlier, we shall pick one of them that is suitable to help us get the answer, one that is having T, A, U, and is required, and S as well. So from that, we will know that we shall pick on this one, S is equal to UT plus a half AT squared. We know that our initial velocity U is 0.25, so it's going to be 0.25 meters per second. Multiply that by the time. So the time taken to, the question wants us to find how far after 3 seconds from time. So it's times 3 plus, that's going to be times a half, times the acceleration, in this case which is 1.5 meters per second squared. Multiply that by time squared, which is 3 squared. We need to find the S. And of course there our value, the distance, when you sum it all that up, it's going to be 7.5 meters. So that's our answer to part A. So part B, they're asking us to find the distance traveled by the particle during the 4th second after projection. So it means that the particle has been moving from here for 4 seconds, but in the 4th second. Now there's a difference if they said find the distance traveled by the particle after 4 seconds, then that is different from saying the distance traveled by the particle during the 4th second. So here they want us to find the particle during the 4th second, not after the 4 seconds. So if we were being, so let's try and withdraw. So we'll try and redraw this. If I may redraw this, this is like this. That's the straight line. It's beginning with an initial velocity of 0.25. That is meters per second. And it is having an acceleration, it's moving with an acceleration 1.5 meters per second. So if it is moving on and on and on up to the 4th second, it means that at right here, the value, the time here is 0. So it moves, that's the 1st second, that's the 2nd second, that's the 3rd second, and that's the 4th second. What I'm trying to say here is simple, that at this point the time there is 0, here the time is 1, after 1 second this is time 2, after 2 seconds, after 3 seconds, that is after 4 seconds. And of course as it's moving after all these times, when the time is 1, 2, 3, 4, the distance covered is also corresponding. So this is the distance covered after 0 seconds at the beginning. Of course there's no distance covered. This is the displacement after 1 second, the displacement or the distance after 2 seconds. This is the displacement after 3 seconds, and this is the displacement after 4 seconds. So if we are to find, when they ask us to find how much has been traveled, the distance traveled by the particle during the 4th second, it means that from 0 to 1, this is the distance covered in the 1st second, this is the distance covered in the 2nd second, this is the distance covered in the 3rd second, and this is the distance covered in the 4th second. So it means that for us to find the distance covered during the 4th second, which is running from this point to that point, it means that we can get the whole distance covered from the beginning. We can get the whole distance covered after 4 seconds. Then we get the distance covered after 3 seconds. Then when we subtract the 2, we're able to get the distance covered in the 4th second. If I'm to make that clearer using different colors, it means that we're going to first get the distance covered after 4 seconds. The distance from there after 4 seconds. Then afterwards, I will calculate and get the distance covered after 3 seconds. It stems from the beginning after 3 seconds right there. Then when we get this whole distance, subtract that distance, we're able to get the remaining part. And the remaining part is the distance covered in the 4th second, and that's what we want. So it means for us to be able to get the distance covered in the 4th second, like the question is requiring us to do, the formula is very simple. We shall call that, let's call that distance S. So to get the distance covered, let's call it S prime. So the distance covered in the 4th second is going to be equal to the distance covered after 4 seconds, which is S4, minus the distance covered after 3 seconds, which is S3. So now right now we need to find S4. What is S4? Meaning that S4 is going to be equal to ut plus a half at squared. What is the initial velocity here? For the particle to cover up to the 4th seconds, initial velocity is 0.25. So 0.25 times the time. The time is 4 seconds plus a half times the acceleration, which is 1.5. Multiply that by time squared. The time is still 4. And of course, our S4 is going to be, so now we get S3. Now, of course, we were able to get S3 from our previous question. Our previous question was asking us to find how far the particle is from or after 3 seconds. So it means that we already know the distance it traveled after 3 seconds from our previous working, or from part A. And part A of that question, which is this here, when we were calculating for the distance traveled after 3 seconds, we got 7.5 meters. So it means that our value of S3 is 7.5 meters. So it means for us to be able to get our answer right here, we are going to simply subtract that the distance covered in the 4th second, which is S prime, is going to be equal to S4. Now we got our S4 as 13 meters, so it's going to be 13 meters minus our value of S3, which is 7.5. And when we get 13 minus 7.5, we are able to get 5.5. So 5.5 meters simply mean that's the answer. That's the distance traveled by the particle during the 4th second. Had the question asked us to find the distance traveled by the particle after 4 seconds, then it would mean that this would be the answer, because this S4 here means that these 13 meters were covered from the beginning up to the 4th second.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.